My name is Patrick Held. I work for the North Dakota DOT out of the Fargo district. I'll be introducing Dylan Jones today. He works for Frontier Precision. Go ahead, take a seat. He's got a presentation here planned for you. Like I said, it'll be on mobile mapping. I'll be shutting the doors here, but looks like we still got a couple people filing in. But anyway, I'm pleased to introduce Dylan Jones, Frontier Precision.
Thanks, Patrick. All right, I'm just going to test this out. Is everyone good to hear me up in the back? So I'm excited today to present on mobile mapping technology, and I'll get into the specifics of it. Just a quick introduction of myself. As Patrick said, I work for Frontier Precision. We're actually headquartered here out of Bismarck. We have locations all across the Midwest and Northwest part of the United States. And we serve as a solutions provider when it comes to mapping and surveying technology, as well as drones and other unmanned systems. We have a booth downstairs. If you have any questions after my presentation, feel free to stop by. I work as a technical specialist. Been with Frontier for about 7 years now, a little over 7 years. In my free time, I like to do some hiking, backpacking. This is in the Tetons early on in the trip when I was still pretty happy. It's a grueling trip if anyone's ever hiked in the Tetons. I have a lot of exciting content to share with you today. Here's the agenda. Mainly just starting with an overview of what mobile mapping technology is, how you can utilize that, where it becomes valuable within your organization, and then how we get that data to be accurate. There's some workflow steps involved with the accuracy side of things. The data extraction side of things is also a very important topic to discuss. Where this fits in various applications. I do have a live demo planned. Cross your fingers, everything goes well. And then a Q&A. So to kick things off here, what is mobile mapping? Typically, where you see this is a vehicle-mounted system, okay, such as a LiDAR sensor. So one of the products that we can get from mobile mapping technology is LiDAR data, of course, from the road or from a drivable location. We would also potentially get imagery. So if your system's equipped with imagery or camera sensors, that information can be utilized almost like a street view, right? So everyone here has probably used Google Street View before. Essentially, you're producing your own Google Street View, 360-degree photos a lot of times with high-resolution information. And when we fuse those together using Office software, we can extract information and get a full sense of what is there, what is in the surroundings in that environment to be able to analyze or extract assets, right? And I wanted to put this graph up here for you to give you an idea of when the price increases, so does the data value. Okay, so if we look in the bottom left-hand corner, what we see is like a GoPro camera, right? A lot of times those GoPro cameras or Garmin cameras, they are a lot of times equipped with GPS information, but at a lower accuracy. So giving you more of a rough position, and also giving you almost a video log, right? So we can get data from that, but where does that exist? Is it accurate? Okay, then we move up towards the upper right-hand corner. The cost definitely increases when you start incorporating high-accuracy GPS or total stations. When you start incorporating LiDAR sensors. Here, towards the middle, is where we start getting into the vehicle-mounted LiDAR systems. Typically going to be somewhere between $200,000 to $500,000. Somewhere in that range. Then you get up into the high-end systems where you have much more high accuracy, outputting a lot more LiDAR information. Okay? So there is a data value increase, though, as you increase in price here. And I'll talk about what kind of data we can extract out of these mobile LiDAR systems. There's 5 key values when it comes to mobile mapping. So the first one, and probably the most important for our employees, right? Safety. Safety is a huge value when it comes to mobile mapping systems. We're driving safely inside of a vehicle and able to do that at highway speeds, not impeding traffic. That's a very big one. Efficiency. Being able to capture that information rapidly. Being pretty much hands-off for the most part. Reducing road, rail, or runway closures. Okay, all of that costs money, right? So reducing the operational costs, reduced field personnel. A lot of times some of these systems you can run with just a single person. Okay, and reducing the revisit costs. Probably had a project once or twice where you've had to send field people back out into the field to collect more information, right? With mobile LiDAR data, you're collecting information at a high detailed or high density output and able to get everything, at least as long as it's within field of view. The simplicity of it has increased tremendously here in the past 5 years. Okay, the software is becoming more and more user-friendly. We're able to run automatic extractions a lot of times. And it's a lot of times just a click of a button. So it's easy to train new staff on how to collect mobile mapping information and extract mobile mapping information. And then you have the completeness. I touched on this with efficiency as well, but in the field you can QA, QC the live capture. You're capturing everything within line of sight, reducing field visits, and creating potentially a 3D digital twin of the environment. That would be the goal. And accuracy, the 5th value there. Projects vary in scope. You may only need sub-meter accuracy. Some of these projects you might need centimeter level accuracy, right? Most of these mobile mapping systems have the GNSS and inertial sensors to provide you a level of detail and a level of accuracy to 2 to 5 centimeters without using ground control. Once you start introducing ground control targets, we can achieve that sub-centimeter, almost millimeter level of precision. So let's take a look really quick. This is a system that I use personally. To give you a sense of what that data capture looks like, this is, I mentioned it's simple, right? There's a record button in the bottom right-hand corner of the software interface. This is actually running on a phone or a tablet within the vehicle. So you're literally just pressing one button. But you can also get a sense of what the accuracy of the system is live as you're collecting the information. You can see where you're driving on that web map background there on the left. You can preview the laser data, is what it's showing you right now. Preview the imagery. Okay? You can load in things like Google Earth KML files to have as a reference so that you know you're capturing all the roads that you need to capture that day. So they've made it very, very easy to capture this information. Once that information is captured, now we need to figure out what to do with it, right? That's a lot of times when you're collecting LiDAR data or imagery, you have this single repository of data that can now be sent out to different organizations or departments or stakeholders on a project, right? So the sharing of that information and avoiding the redundancy in capturing the same information over and over again by having this centralized spatial data repository is a very key component to things. You can keep historical records, and there's online platforms to allow you to share the information and collaborate better with stakeholders in a project. And for the most part, you know, the key to collecting this spatial data is to be able to make decisions, right? to be able to make those decisions faster because we are collecting that information at a high rate. So think about where this spatial data, this mobile mapping information can be utilized within an organization. So once we get that information into the office, we need to assess the accuracy of it a lot of times. So based on the project scope, we might not need to do any post-processing or any registration, but there are projects that require high accuracy and a high level of detail and tolerance, right? So first step with many of these systems is to post-process using a base station. So when we talk about post-processing, we're analyzing the location of the sensors, right? So we're getting this trajectory through this post-processing workflow. And when we introduce a base station, like in the picture there, we have a base station usually set up on a site, logging static data to be able to post-process against for our GNSS solution. From there, we take that into whatever software package we're using. So for example, Trimble Business Center is what I use to perform ground control registration. So when we need that high level of accuracy, registration is extremely important. We need to be able to know, does our collected information hit the control on our project site? Other things we might be using Trimble Business Center for is for feature extraction, viewing those panoramic photos, CAD drafting, surfaces, measurements, and then potentially even exporting that information to a more specialized software where we're doing maybe pavement analysis, right? So what does that registration look like? Just a quick preview. On the left there we have a top-down, that's actually showing a point cloud, a colorized point cloud of a target. So that white target there, and there's a small triangle, sorry for those in the back that can't see that, but there's a small triangle that indicates where our ground control point as surveyed by traditional instruments. So we take that information from our traditional instruments and we incorporate that into this registration routine to essentially calibrate or localize the point cloud to a high level of accuracy to match that ground control point. So on the right-hand side there, we see a cross-section of the before and after the registration. Here's a quick example of a project that I worked on where we had these chevron shapes painted on the road surface. So if you've ever driven down a highway or a road and you've seen these chevron-looking painted targets, those are for mobile LiDAR typically. So as we drive down the roadway, we're collecting not only everything around us, but also specifically those targets. And those targets tell us where our control is at. Spacing-wise, it's important to consider, based on your accuracy requirements, how far we space those targets out. So a lot of information here, but essentially, when we need high level of accuracy, we need those targets to be spaced closer together. Typically on an urban section of roadway, we would say somewhere between 300 and 800 feet between targets. On a highway scenario, typically around 1,000 to 1,500. But the more the better, okay? The more spot checks you can have. In between, a lot of these targets, so the painted targets, do take some time at the beginning of your mobile LiDAR project. But in between those targets, we typically take like a GPS shot on the road surface to give us some sort of validation in between the targets. So we know that in between, we have still accurate data, right? Something to compare. And remember, mobile LiDAR, mobile mapping data is only as accurate as your control. Okay? So consider what control techniques are we using to obtain positions on those targets? Is it using just an RTK solution, static GNSS, total stations, a level of sorts, right? What's acceptable for your project? It all kind of boils down to what the scope is and what the tolerance of your project is. Now we get into the fun part, right? Producing deliverables from mobile mapping data. So I just created a list here. These are a lot of the things that people are using mobile mapping data for today, especially assets, collecting positions on assets along a roadway, line work to create surfaces, surface models, volume calculations. Maybe you just need a quick measurement, a clearance measurement for that matter. Collecting information before a project, after a project to do clash detection and analysis that way. And very simply, image documentation, right? So I've worked on projects where the clients needed to log, essentially a video log on a roadway with high accuracy position and assess what that roadway looks like after construction to see where did things go wrong on my roadway, how much should I be charging the contractor for the damage, right? So things like that. You can get creative with mobile mapping technology. Other more specific things that I'll actually demo for you. Feature extraction of trees. To be able to go through and automatically extract the trees along a roadway to keep an inventory. It will actually also automatically measure heights, diameters of the trunk, and diameters of the drip line or tree spread, right? So smart information coming from the software there. Poles, same deal, heights of poles. At what angle is it leaning? Signs, same detail. Heights, locations, diameters, and if there's any inclination. Here we get into surface models. Okay, so highly detailed surface models for that fact. When we go out and traditionally survey a roadway to collect cross-section information, probably doing that probably no more than 25 feet down a roadway. This is collecting information at centimeters of spacing, and that way we can create a very detailed surface model and get accurate quantities if that's what we're looking for at the end. And being able to take that as built or surveyed, to take that point cloud, convert it into a surface model, and then compare it against a design to know where these quantities are coming in from. Measurements, height measurements, slope measurements. If there's an ADA project, something like that, we can drive around the entire city, collect that information, and be able to pull very, very accurate measurements on all of our ped ramps or sidewalks. Here's an example of vertical clearance measurements. With just a click of a button, we can get quick power line or bridge clearance. Here's an example of utilizing mobile LiDAR data for pavement condition analysis to calculate a PCI, which I know there's a lot of people in this room that work in the materials or transportation departments of an engineering firm, right? So being able to collect this information by driving down a roadway, feed it into a software to analyze and detect where there's rutting, potholes, cracks, okay? Rather than doing that manually by sending people out in a car and giving it less of an objective score, right? Photo documentation, street view verification to make sure you collected everything. So this is actually showing you locations of trees with the symbology. You can see the center line, CAD line of that roadway. And then here's an example that I have where you can easily just create a quick 360-degree YouTube video from that imagery and quickly give that to someone so that they can essentially drive down a road, see if there's any issues, like if there's cracks or areas where we need to do some maintenance. So this is something that's very easy to make, and it can become very powerful as well. And to go along with that, right, sharing that information to other people within the organization or to clients, we can upload the entire mobile mapping data set to the web. You can locally host it. You can host it on a cloud. But essentially, being able to publish this information and allow people to go in and extract or measure or view the entire data set. It doesn't require them to have any software installed on their computer. They're just going to a web link, right? Here's an example of a project that I helped out with. It was a signalized intersection inventory. But just to give you an idea of, this type of survey is very difficult to do with traditional equipment, specifically because a lot of these intersections are very, very busy, high traffic, high volume traffic areas. In a nutshell, each of these corners of an intersection have like a dozen different components to map out, especially like the signal heads, the mast arm lengths. There's measurements and other attribute information to extract as well. So keep in mind, this is difficult to do if you can't get out underneath the signal head to understand where exactly that signal head is at with an XYZ position. So using mobile LiDAR or mobile mapping data, we can extract all 1,127 assets within 24 hours. And that takes into account the time it took to collect the data. Okay? And software is getting smarter and smarter. There's a huge increase in productivity when it comes to working with point cloud information, using computer-assisted point and linear feature extractions. So to get that 3D CAD or GIS information, I'm using something called Trimble Business Center to do those extractions. And I want to show you how powerful that can be, how easy it is to use. These are some examples of where you could potentially use these automated extraction workflows. To give you an idea of how much time it saved on one project, we had to go out and collect information on the curb and gutter. We extracted using traditional mobile LiDAR extraction, where we're clicking on points manually every 30 at a 30-foot cross-section interval. That took 3 hours and 12 minutes to do on this stretch of road. When these new linear feature extraction tools came out, we ran that same extraction again, but just feeding the point cloud data into the software to automatically extract it at a 5-foot cross-section interval. 58 minutes. So an incredible amount of time savings there in that example. And I wanted to just show you the wide range of applications where mobile mapping technology can be used, right? So if it's something in a specific vertical here, right? DOTs and highways is where we see them being used the most, but utilities, mining, energy, rail, right? There's other avenues to utilize mobile mapping technology, and the things that you can get out of the mobile mapping data is quite extensive. So I wanted to just share a few of those examples here where I've seen people utilize mobile mapping data. And it doesn't always have to stay on a paved surface, right? You can mount these mobile LiDAR systems to off-road vehicles, ATVs, get creative that way and be able to essentially drive it wherever you can drive an ATV. So are there any questions so far? I'd like to give you a taste of what that data extraction and what the data in general looks like in a software. So let me open that up. There we go. So apologies again to those in the back, but this is a mobile LiDAR data set showing in 3D. So I can rotate around. And this is actually a think this was an 6 to 8 mile stretch of roadway that was collected for a training that I did on a mobile LiDAR system. And so I'm going to focus on this smaller section here of this roadway and show you some of the powers of these feature extraction tools. So to start with, we can utilize the mobile LiDAR data to just visualize, just to get a sense of what's around us, what's in our surroundings, utilizing 3D views or utilizing other views such as station views. Oops, I'm sorry. I'm actually looking for a different button. Let's go here and open up a panoramic view. So if we want to visualize that 360-degree imagery, here we have it. And from this view, we can perform extractions or just overlay point cloud, line work, GIS data, all within one view here. So if I switch over to a full view, which will show my point cloud information, I'll turn on the point cloud. And the point cloud's actually on right now. It's just colorized. So let me change the color. And I'm actually going to move it to this sample area that I have. There it is. So I have a surface model. I have some line work that was extracted. The point cloud is displaying. And that's all just coming in from the field without any additional calibration needed. So we can utilize that panoramic view to to do what we need to do in regards to data extraction. Here, what I want to show you as I turn off the point cloud, this would be essentially an end product, right? I have my surface model, I have some line work, contours, some points that were extracted. Here's like, for example, curb, a little curb section there. So I want to show you how I get to that. How do I get to that point? Let me turn off some of these layers and show you. Turn the point cloud back on. Turn it over to a true color view. And let's begin with just some basic point extraction. So point extraction of these trees, for example. So what I want to do here is just kind of clip out this area to make it a little bit easier to see everything. And so I have some trees over here. I want to extract those. I want to get a position. I want to get a height. So let's do that. Opening up my extract point feature command. Right off the bat here, it's going to say that we recommend that you classify the point cloud. So if anyone's worked with point clouds or LiDAR data, there's this thing called classification to essentially put the point cloud on different layers. So for example, high vegetation, ground, buildings, things like that. I'm going to switch over to extracting trees, and then I'm going to hit the automatic button and hit go. So essentially the software is sifting through this point cloud data set shown on the screen, and it's looking for tree objects. And so within, 5-10 seconds there, it was able to detect where all the trees are in that selection of point cloud data. So that quickly we were able to detect, well, let's see how many there are here, and we can provide coding or attribute information to those objects. So what I'm going to do is map the auto-extracted measurements and then I'm going to hit add. 17 points with the broadleaf tree feature code are going to be added to my project. I'll do that, and now I have those symbols representing, those are actually scaled to the size of the tree, which is pretty neat. So I'm going to close that tool, and then let's take a look at one of these points. Look at the properties of that point. And I can see here that that tree is 18 feet tall, has a trunk diameter of 1 foot, spread of 13 feet, and then I could also populate from a pick list here the species, right? So being able to do that, and you could also provide a photo. Let's take a look at some line work. So I'm going to extract a section of this curb here. So if we zoom in, this is the curb. I'm going to use my curb and gutter tool. What this does is it essentially cuts a cross section through that curb. And then what I'll be able to do is pick out the identifiable shape of that curb. So we can see the top back of the curb here, the face, the flow line, and then if there's a lip to that gutter. Essentially what I'm doing is picking out where those are located to essentially give the software a sense of what I want to extract for brake lines. And then now I just point it in a direction that I want it to go. I can extract it at a custom interval. So let's do an extraction every 1 foot down that curb line. Hit the go button, and now what you're going to see is it automatically tracing out that curb until it runs out of appropriate data. So here, the data starts to get sparse, but we can still make sense of it with the human eye and continue the extraction if needed. Let me stop it. I'm going to switch direction. So essentially by switching the direction now I can go back in the opposite direction, hit the go button, and just within a minute or so I have this high detailed extraction along this curb radius. All right, so I'm going to finish that. I'm going to create the line work. So there's actually 4 brake lines that can be drawn there. I can remove one of the brake lines if I don't need it. But let's go on to the next thing. The next thing is going to be lane line markings. So lane line markings meaning the pavement lines, right? So we have this fog line on the road. I'm just going to simply click on it. The software is going to detect the basically a reflectance value. It's called intensity. And hit the extract button. So now what it's doing is it's going to trace out that pavement line until I run out of LiDAR data there. Switch direction, hit the go button, and now it's going in the other direction until it can't go any further. I'll create that as a 3D polyline and go on to the next one. Okay? So this is where we're starting to see a lot of value in utilizing mobile LiDAR technologies. The software is finally at a point where it makes sense to do so. Okay? In the past where we didn't have these automated tools, it did take quite a bit of time to do this all manually in the office. Now granted, being in the office is a lot of times a lot nicer than being in the field, especially in our North Dakota winters. And we can also utilize this for overhead lines, so power lines and other overhead utilities. So the way that this works is you give it essentially a start point, an end point, and then you pick out your lines. Okay, from there, you can have the software automatically find other lines that might be in the vicinity. So there it just picked out several others. And now all I need to do is hit the extract button. So I'm going to zoom out and show you what that looks like. It's essentially just tracing along those power lines. From there I have 3D CAD line work. I can create those and export those out to an AutoCAD project or wherever I might be using this data next, right? So those are 3 examples of utilizing linear feature extraction. The rest of this would be more along the lines of maybe some manual point or line extraction. So you can also do things more manually. Once you extract your brake lines, from there utilizing the point cloud and those 3D break lines to create a surface model. So essentially, I'd go through that process next. I'd select this point cloud data set. I'd remove the trees using an auto classification technique, and then from there, select my lines, that point cloud, and then end up with a surface model, which would look like this. And that's very highly detailed, right? This is more than what you would typically measure when you're in the field with traditional survey equipment. Okay, so let's see, is there anything else that, I think that's primarily what I wanted to show here as a live demo. If there's any other questions in regards to what other tools that are available, other workflows or techniques for extracting data, feel free to come find me. But does anyone have any other questions for me right now? Yep. This is Trimble Business Center, yes. Yep. Yes, dashed lines. Yep. So the question was, can it also draw the line work for dashed pavement markings? The answer is yes. So it'll go through and be able to detect those dashed pavement markings. Yep.
You were talking about the reflectivity. Is that just at the pavement markings?
Every return, every point in the point cloud is going to have a intensity value attributed to it. So that's from 0 to 255. The white or highly reflective surfaces are going to have a stronger intensity return than the ones that don't. Or like, for example here, the easiest way to see that is on asphalt surface, right? So this is a prime example where this is an asphalt surface road. We have those pavement markings. That white or yellow pavement line stands out tremendously. Even just from your bituminous to concrete there, right? Hopefully you can see that with the lighting of the projector, but there's a very definitive break between the surfaces. So we utilize that intensity view quite a bit when we're determining where our break lines or where the edges of our pavement are located. Well, if there aren't any other questions, feel free to reach out to us. I don't know if anyone drove in or flew in from other locations, but we do have a dozen or so offices scattered throughout the Midwest and Northwest part of the United States. So if you need to get a hold of any of us, any of our offices, here we go. Here's our phone numbers and our locations. But thank you for attending, and feel free to find me downstairs if you have any other questions in regards to mobile mapping technology.